Hello and welcome everyone. In this video, we will look at the data loading and QC step in the microseismic data processing workflow. We load all relevant information including survey geometry, recorded waveforms, well logs, and velocity model, typically onto a commercially available or proprietary processing package. During this step, we make sure that all the data use consistent units. The spatial position and survey follow a consistent coordinate reference. We also apply the deviation surveys to all survey geometry to get correct trajectories for the wells and for correctly placing the calibration shots, stage locations, and receiver positions within these wells. A visual inspection of the survey geometry helps validating the spatial position of the wells, stages, receivers, and calibration shots, and also that these make sense with respect to the reservoir depth. We should also check waveforms and header info for any inconsistencies or anomalies. For example, headers not placed correctly, dead traces, background noise variations for some periods, and so on. And we should also refer to observer log or field notes if available, as many of the observations that we make on the waveforms and geometry during data loading typically have an associated explanation in the notes. So these are very useful. A deviation survey file typically contains information about measured depth, inclination, and azimuth. We can use this information to calculate trajectory in terms of x, y, and true vertical depth. We can use any of the available methods, such as minimum curvature method, to do these calculations. In these expressions, I represents the inclination and A is the azimuth. Index 1 is, say, the first row in the table, then index 2 will represent the row below. The task for you is to use the minimum curvature method and find the missing values in the table. Please leave your answer in the comments and I will also share the solution. Thanks for watching this video. Again, don't forget to subscribe to my channel and see you in the next video.